Okay, so welcome to this session. We will be discussing today as why the orientation sometimes can be towards ortho and para, and the orientation sometimes can be towards uh, meta. Okay, so the essence of all this is basically the nature of the substituent group on the benzene ring. So basically, we have two types of substituent groups. We have a group that is um, orienting to ortho and para, and these are called electron donating groups, and other groups which are donating or withdrawing electrons, and these are called deactivating groups. So let's take that. So the first type is electron withdrawing groups. These are deactivating, and essentially they will direct to meta, and electron donating groups. These will be activating, and they will give you a mixture of products of ortho and para. Okay, so how do we differentiate between the two? Electron withdrawing, electron donating groups, something would have, um, for example, a nitrogen or oxygen with no double bond, where basically the lone pairs of electrons on the nitrogen or oxygen will uh, interfere with the delocalization, and they will enhance the electron density on the benzene ring. Okay, let's take an example. Okay, now in this case, let's take aniline. And see what happens. Okay, now aniline is regarded to be the electron donating group. The lone pair of electrons can form a double bond with this bond here between the carbon and nitrogen, and therefore this bond can break into this direction. Therefore, the structure here will be okay. Now there is possibility that the electrons here will form a bond, and the bond will break and form a formal charge on this carbon where I pointed. And also there is a probability that the electrons will form a bond here, and this bond will break and form a negative charge on this carbon. And finally, these electrons can form a bond here, and this bond can break into this direction. Okay, and this is basically the structure that we have started with. Now, these structures, we call them resonance structures. So what does mean resonance structures? Resonance structures are basically um, are the structure are the possibility of how the electrons can revolve around the benzene ring or any other system similar to the benzene ring. So there's possibility number one, two, three, and four. Fine. Now, what can we notice from here? We can notice the following things. Um, what you can notice here, that you have formed extra negative charge or more uh, electron density, if you like, around the ortho position, around the para position, around the ortho position. And this essentially is what causing the electrophile to be attracted to these sites. As you can see here, neither of these structures formed a negative charge on the meta position. And that's why when you use a group such as electron donating group, they will direct the incoming groups towards these sites, the ortho and the para. Okay, now let's take a different group, and this group here is an electron withdrawing group, and see what will happen. Okay, an example of this is this compound. And here we have electron withdrawing groups. So in this basically electron withdrawing group, it will cause the electron density in the benzene ring to be reduced. And this is because it has the ability to interfere through the double bond on this group. So how this can happen? Now, to start with, uh, the electrons will be withdrawn through this bond, and therefore it will here the bond will break and will form a double bond, and the bond as a result will break into this direction. As a result, we will be getting something like that. Okay, another possibility here that the electrons will move to where I pointed. Another possibility that the electrons will move into this direction. And here we have a double bond. Okay, so what have we got here? We've got here these interesting resonance structures. Now, in these three resonance structures, what we can see that we have created a positive charge in the ortho position. We have created a positive charge on the para position, and also we have created a positive charge on the ortho position. So what does that mean? It means that this incoming A plus, it will repel against these three position, whereas the position meta here still have some more electron density that can attack the incoming A plus. And therefore, the meta position here will be the preferred site if you have an electron withdrawing group. Okay, so this basically the reason behind why some groups are directing towards ortho and para, and why some groups are directing towards meta. Now, these structures, this drawing is not required for the exam, and therefore it's only for your understanding. Okay, thank you very much. And I may follow this video by another one to explain this in slightly different example. Thank you.